Hello and welcome, or welcome back if you're here because you saw my previous ice melting video. Either way, I'm glad you found your way here to do some at-home science with me. I'm Dr. Kara, I'm a STEM educator, and I am bringing some fun science to you. Today, we are going to learn how salinity, that is, how much salt is in water, affects how quickly ice melts in that water. And you are going to do the experiment right along with me. Last week I posted a video with this demonstration that shows ice definitely melts at two different speeds in salt and freshwater, but I didn't tell you which was which. Today, you are going to join me in repeating this experiment and we will find out together. And we will take some additional steps to learn why this happens. So, get out the hypothesis you wrote down last week, or if you're joining us for the first time, take a moment to write down a hypothesis now about whether you think the ice melts faster in the saltwater or the freshwater. And then continue with the video to find out. If you need to, just press pause to give yourself some time. To do this experiment together, the first thing we'll need to do is gather our supplies. Make sure you have an adult help you with this part so they can help make sure you're gathering supplies that it's okay for you to use. You will need 2 clear containers of the same size that can hold 1.5 to 2 cups of water. As you can see here, this can be 2 glasses, 2 jars, or even 2 bottles with the tops cut off. Just make sure to have an adult help you if you're cutting bottles. You will also need salt. Again, that kind of salt doesn't matter too much, though I do recommend salt that has smaller crystals, as they will be easier to mix into the water. You'll need about 4 cups of water. You will need food coloring, and of course, you will need ice. But you can go ahead and leave that ice in the freezer for now. The first thing we need to do is make ice. If you already have ice in your freezer, you are all done with step 1 and you can move right along to step 2. If you don't already have ice in your freezer, go ahead and fill up an ice cube tray, put it in the freezer so that water has a chance to cool down and turn into ice. Just press pause if you need some time to do that. The next thing we need to do is make our salt water. To do this, we are going to dissolve salt in water. What we'll need is about half a cup of hot water. The hot water that comes out of the tap in your sink is more than hot enough. Then you are going to add about 1 to 1.5 teaspoons or half a tablespoon into that water and mix it in. You can do this in a separate container or in the container you'll be using for your experiment. It may take a couple minutes to mix all of the salt in because we're adding quite a lot. You can stir it with a spoon or you can swirl it in. Just be careful that you don't spill. Once that is done, set your salty water aside and proceed to step 3. Now we need to fill our clear containers and make sure the water is the same temperature in both of them. The best way to do this is to pour your salt water into your clear container and then fill to the top with cold water. Then fill your other container with just the plain cold water. Next, simply let them sit on the countertop for about 2 hours, or if you put them in the refrigerator for about 1 hour, that should work too. Remember not to fill all the way to the top because you don't want the cups to overflow when you put your ice cubes in. Once your water has gotten to the same temperature, it is time to add our ice cubes. If you are using large ice cubes like those from an ice cube tray, add 1 to 2 to each container. If you have smaller ice cubes like the ones pictured, add 2 to 3 to each container. And then observe what happens. Watch the ice cubes for a few minutes. What do you notice? Do you see anything happen? You should start to see some differences in about 5 minutes. And once you start to see those differences in how quickly the ice is melting, then you can move on to the next step. Go ahead and press pause now until you are ready to move on to step 5. Remember, that'll take about 5 minutes. So observe closely and see if you notice anything happening. Now is the time where we see what is going on. We're going to add food coloring to help us see what is happening inside these cups. Add 1 drop of food color on top of 1 ice cube in each of your containers. Any color is fine, just remember that darker colors will be easier to see. Observe what happens to the food coloring. Where does it go? Does this help you understand what's happening in these cups? Continue observing and think about why you think the ice is melting at different speeds. Feel free to press pause while you observe and then continue when you're ready for the explanation. So, to find out a little bit more about what's going on here, let's watch that again from another angle. And we will see which container the ice melts faster in. By now, you should know from your own observations. So let's take a look. Wow, that's interesting. The food coloring is mixing all the way into the fresh water, but it stays at the top in the container with salt water. That's really cool looking, but why does it happen, and what does it have to do with this melting speed of the ice? Well, it all has to do with something called density. Simply put, density is how much stuff is packed into a space. As you can see here, I've got 2 circles on the screen. They are both the same size, but if we take a look inside, we can see that the purple has less stuff, less smaller circles inside it than the green one. So the purple circle is less dense than the green circle. Things that are less dense will float on top of other things that are more dense. For example, have you ever noticed that the oil and vinegar in your salad dressing tend to separate? Well, that's because oil is less dense than vinegar, so it floats on top. That's why you have to shake your dressing before you use it. So, getting back to our experiment, there are 2 things affecting density that we need to discuss. First, how much stuff is packed into a space, as we've already discussed. So, if we start off with 2 glasses of water as illustrated here, but then we add salt to one of those glasses, we have packed more molecules, more pieces of stuff into that same amount of space. And so we have made the water more dense. Salt water is more dense than fresh water. The other important thing to know for this experiment is that temperature affects density. Liquids that are warmer are less dense than those that are colder. This has to do with how much each piece of matter is moving. The warmer something is, the more energy it has, so it moves around more. If it is colder, it has less energy and doesn't move around as much, so it can pack in more tightly. Have you ever put a bottle of water or soda in the refrigerator, and then when you take it out, you notice that that bottle has sort of caved in a little bit? That's because the liquids and gases inside the bottle shrink a little as they cooled. So, the important point here is that warmer water is less dense than colder water. So now if we go back to our experiment, remember, we have 1 cup of fresh water and 1 cup of salt water that started out at the same temperature. As the ice melts, something different happens in each condition. In the freshwater cup, the cold water melting off the ice cube is much colder than the water in the rest of the cup. Because remember, water freezes at a temperature of 32 degrees Fahrenheit or 0 degrees Celsius. So the water melting off of the ice cube is only just above that freezing level, which means it's much colder than the water in the rest of the cup. That means it is more dense than the rest of the water, so it sinks to the bottom. As it sinks to the bottom, it pushes the warmer water in the rest of the container towards the surface. This means that the ice cube is constantly surrounded by that warmer water, so it melts even faster. On the other hand, in the saltwater cup, even though the water melting off the ice cube is still just only a little bit above freezing, it's still less dense than the salt water because it is still a freshwater ice cube. So what happens here is that cold water melts off of the ice cube, but it stays right at the surface, making a little layer of almost freezing cold ice water at the top of the cup. So that ice cube becomes surrounded in a layer of water that's only a tiny bit warmer than the ice cube. So that helps to insulate the ice cube. That means it helps keep the ice cube cold, so it melts more slowly. The food coloring helps us see these two different effects happening. So let's take a look at our video again now that we know what's going on here. As we watch this video again, you might notice that the ice seems to melt around the same speed in the cold water and saltwater cup at first, but as that cold water layer develops in the saltwater cup, the melting there slows down. Once we add the food coloring, we can see the movement of the water as the cold water sinks and the warm water rises in the freshwater cup. And we can see that nice clear layer of fresh water at the top of the saltwater cup. So let's take a look. The ice is melting. We add the food coloring. We can see that it sinks to the bottom and then swirls back to the top in the freshwater cup. And we can see that nice clean layer at the top of the saltwater cup. I hope this makes it clear how and why ice melts at different speeds in salt and fresh water. But what do you think might happen if we change the temperature of the water? If they were both very warm or both very cold? If you decide to try that experiment yourself, I would love to hear about what happened. Feel free to leave me a comment or some photos or videos of those experiments or of what you did for this experiment, or if you have any questions. In the meantime, thanks for watching, and don't forget to check back soon for more cool science. If you enjoyed this video, you can also follow me on Instagram and Twitter. I'll be posting new content on all different science topics as often as I am able. I hope to see you again soon.